So I was not sure if anyone would attend to a talk about Python project configuration, but I'm happy that you are with me with this exciting configuration stuff like in the world of AI. But to be honest, I was excited around 1 year ago when I find the final piece to present the things that you will see today. I was really excited, but why? Why I got excited? Well, to explain that, we need to talk about dominoes, but more specifically about the domino effect. You line up dominoes, right? But instead of using the same size pieces, you scale each one up. So each piece is the maximum size to be down by the previous one. So if we start with a regular size tile at the beginning, the time you hit tile number 23, you will be able to flip the Eiffel Tower. By the time of 34 tile, it will be bigger than Mount Everest. So domino effect is huge, having huge impact. And imagine that your project, you are starting fresh project, and your first decision is to make configuration as static variables, global variables in your project. What could possibly go wrong? We all like global variables, right? But then we have a next decision. Okay, we have these global variables that are easily accessible through all the code. So through all the code, we are start using if statement in our functions to check if we should go with this flow or another flow. And this way, the domino effect starts to piling up and more bad decisions are taken. And after some time, you got yourself a lovely message. Welcome to Legacy World and the pain. So I don't understand what it takes so long to add a new window. Probably it started with the simple bad decision at the beginning. But I have a really good news for you because the domino effect works both ways. So if you start making good decision, and it doesn't need to be at the very beginning, but if you start doing good decision, they will work also like a domino effect, and it will be easier to start making them more. So today I will show you what the first good looking domino is for me in the project, and that will help you build a solid, maintainable, and honestly fun to work with projects. My name is Grzegorz Kocjan, and I've been programming in Python for 14 years. I run local meetup in my city, Łódź, and I work at IndieBI and like to share knowledge at my Be Lazy Dev blog. You can find there all links to my social media, so if you will have any questions and etc., you can write to me directly. I really respond to people. And I'm trying to be as much active as possible on those social media, but keep in mind that I'm also a father of two small children. So let's get back to the topic. Are you afraid of the dark? It was an old TV and cheesy horror series for teenagers, and I will show you some of my coding and config horrors from the past. Season 1, Episode 1. Everything as a separate global variable. How to change config on production? We have several ways. The first one that I saw on my first job was we can assume that there is some local config file that exists outside of the Git repository, and we somehow transfer it to the production. And this file could look like this. What was the worst? I constantly was finding variables that were defined only in this local file, used all over the code and not defined in the main config.py file. Lovely times of Python 2.7. Okay, but we can do better, right? And we can improve it quite easily. So instead of loading this local file, we can use environment variables. But this line looks a little bit over-engineered, I think. It's like lowering, comparing to the strings. Probably what you would do at the very beginning would look something like this. So get environment variable with the debug, and default value is Boolean value true. But what can go wrong? So, for example, if we have this if lovely statement with the debug, we then delete all the users if we are in the debug mode. So we want to have every time clean environment to check some stuff, to reproduce some bugs. So let's imagine that our DevOps team have decided we need to be 100% sure that on production we will never delete all the users. So we'll set up debug to the false. What happened? Because the environment variables are always string. So string with the content false equals true. So we are deleting all the users. Bye-bye. But honestly, the worst of them all, and that was scary one for me, Ansible magic. I love Ansible, but this was Ansible magic to generate dynamically JSON config files in Jinja template. And it was one-liner. It was that big line that no one won't touch and was doing all the configuration based on Ansible configuration to transfer the configs from Ansible to the production. It was nightmare. Nobody wanted to touch that place. But finally, I found a happy place. And finally, somebody created a library that I wanted to write by myself. And it's called Pydantic settings. What can you do with Pydantic settings? Well, there is one thing that you probably don't know yet about me. I'm TDD maniac. So we're gonna write some tests to explain what we can do with Pydantic settings. So let's have some tests. We use monkey patch fixture from the PyTest to set environment variable debug to true in our test. And we will have assert false as this test is not finished yet, and it is a good marker for me that, okay, there is still some work to do. We need to figure out what we want to have in our system. So we would like to have some class with settings that will have property debug and that it will be equal to true because of this debug environment. So now we can precisely set the name of this test. And implementation is really simple. This test is passing when we just create this settings class, and it inherits from base settings, and it has only one field debug with the type bool, and everything works perfectly. Okay, what we can do more? Every system, like most of the system, have some kind of DB, so we can say that, okay, I want to set up DB host and pass it to my configuration. So I set DB dunder host as a non-local variable, so it is some value. And I like to use dunder, so double underscore, between the environment variables to distinguish some groups. So I have a group of DB configuration, and there is a host value. So double underscore separates those values from each other. So I still have my settings class, and this time I want to have DB property and host property that equals non-local. And of course it doesn't work because we are in TDD and we still didn't write any code. We just write our expectation. So how to add this? We start with adding another simple class, DB settings, with the host string, and we use it to define the type of DB property. Will it work? No, the test is failing. We are missing some piece. Yes, by default, if we have nested variables in our settings, Pydantic will use single underscore. I prefer double underscore because it is easier to map what is in the objects to what are in environment variables. And now everything works as expected. If this simple example works, I can add more expectations. So DB host, database name, username, password, and all those fields will be generated from environment variables. And implementation is really simple, but it works. Is just it? Boring. That was the documentation stuff. I want to introduce you how Pydantic setting works, but we want more, and we want more cookies. Now the web is full of the cookies. We want more features. So we want to have different kinds of databases. So on the production, we'll probably use some mature database that has configuration with host, etc. But SQLite has different kind of configuration. It is database that is stored in one single file on our local drive. So instead of all those configs, we need path and only path. And what would evil programmer do? What would AI do? Well, we have this class, right? So the simplest solution would be to add another property to it. But there is a problem. We cannot set all those fields. They cannot be all required. Why? Because we need to sometimes pass 4 or sometimes pass only 1, the path. So we make all of them optional. And the Skynet is happy. It's taking over the world. No, don't do that. Instead of adding another property to the place where it doesn't fit at all, create separate classes. So we have Postgres settings that precisely have all the fields required. And we have SQLite settings that have only one property required and is totally different from the other. But now we have another challenge to solve, because we want all those two classes to fit into one DB property in our settings. How to do that? Well, we can use union and tell, okay, we want this configuration or this configuration. But out of the box, it will not work. Pydantic settings don't know which one to choose, and he needs to choose it strictly. So we need to give him a little bit hint. So in our classes, we need to introduce a new field type. And type for Postgres is literally only one value Postgres. And for SQLite, it is literally only one value SQLite. And having that type property, we can tell that our settings, DB settings, are PostgreSQL SQLite, but the discriminator of the type is field type. And that's why with small changes in our test, so we will add those types to the Postgres settings and it will work. We'll add the type for SQLite settings, and then again it is all working beautifully. So this is the best configuration in the world that is really, really powerful. If you have complex system, it will give you a lot of benefits that we'll shortly describe. But of course, I am an engineer. I can always improve something. And thanks to Python changes, we have also something like annotated syntax. And we can create type aliases. So if you have some complicated types, use aliases. It is much more legible in your code to use them. And in our settings class, we can use them with annotated syntax to determine how these fields should be created with the second argument of annotated. And it is much, much better syntax than the previous one. Why? Let's analyze what was in the previous one. So we have our field DB, we have our type, we could use the alias here also, but what was the worst was this equal sign. We were lying that after equal sign, this is a default value of this property, and it was not. It was only some kind of metadata, and it was a lie that it is a default value from the syntax. So it was kind of confusing that we have default value after equal sign, and it was not a default value. So that's why I really like annotated syntax, to be precise and say DB doesn't have a default value at all. So I was telling you about some opportunities, and with that configuration, we are opening doors to a new, better world. So how we can use this configuration? So with our database, with our SQLite settings, we want to, for example, generate relative URL. So if we are using SQL Alchemy, where we can pass, for example, the whole database URL to it, not our object, and connect to different kinds of database based on this standard URL. And for SQLite settings, we can just initialize this single class. have some expectation, and assert it. And that's it. Of course, it's still not working because we still not implemented it, but we can easily add that functionality responsibility to our class. So we have our property URL, and based on that, we can define how path looks like. So we can extend this simple class to have more features that are in our domain, and this is the right place to put that feature, not something somewhere else totally. And the test is passing. The same we can do with Postgres settings. And as you can see, it's much more complicated to generate the URL for Postgres database, and it even didn't fit to the screen, right? Because it was too long. But having a good test, we can check everything. And why I like this approach? Because here in our tests, we can precisely verify all the variants of this URL, how it is generated. This is really simple implementation. There are different options that can be added to the URL, and they are quite complicated. And imagine that usually people are building this complicated URL in Terraform or infrastructure, and it's really easy to make a typo in all of those signs. But if you are using as a configurations separate values that are quite atomic and building complex thing in your code, it is easily unit testable in many different ways. But that's not all. We can go deeper and open another doors. And because it will be a little bit more complicated, we need to build some real project. And this is another thing about me. I'm Star Wars fan, so we will build a Star Wars fleet calculator that will calculate the cost of our fleet, how much credits we will need to spend. So what I want from what I want from my project. I want to have a test that explains that, hey, I want to get information about starships, right? So I have a client. It is a fast API client, and I use test client to run it. So I'm running get starship /10, and I have status code 200 and some JSON response. By accident, it is Millennium Falcon that we are returning, and we know that it costs a lot to produce it. How to implement such functionality? Because we are using TDD, so the test exists code no. So we start from creating a basic base model Pydantic. It's not the settings, but the raw Pydantic with all the fields. And we are creating a client. And for now, I want to build the whole structure, test the simplest scenario. So for now, the client returns the static data. In the future, I have in mind that all the Starship data will come from different service. So I will need to do external call. But for now, I use this simple implementation just to wrap everything around. So I need to build an endpoint. So just decorate the function, call the client, initialize the client, call the get Starship, and the test is passing. So with static data, I just build the whole flow, check if everything is correctly configured, and it is. I want to do something more, so I want to have a cost of the ships. So for this ID 10, I want to just return the cost, and I have response only with the integer value. And of course, it not pass because the endpoint doesn't exist. And it is really simple. It's very similar to the previous one, but now we are only returning this cost in credits value from our object, and test is passing. But here I don't like one thing. We have a code repetition. We are initializing the client every single time we need it in the endpoints. So what we can do with that? We can use dependency that is built-in functionality in FastAPI. So we have our factory, the one place that knows how to create a client. And we have alias for annotated syntax when we tell that, okay, we will return Star Wars client and use depends. So it is a FastAPI feature that will tell that each time you want Star Wars client, you will run this function. How to use it? So instead of calling it directly, we use arguments. So we are telling that when somebody will call this endpoint, we will get the client using this dependency. Okay, but am I still talking about settings? Yes, because now we want to expand our functionality. We will not go to the production with static implementation, right? We can give our front-end guys the API that works on static data and let them work while we will start implementing the real API implementation with the connection to the external service. How? So, well, let's describe the configuration. We have the static configuration that we are currently using, and it is only one thing, but we want to have also API settings that have some basic URL, and all the types are here like previously. And we have in our main settings client that is annotated, and right now we have default value after equal sign that is a static configuration. And instead of having our client directly implementing the static configuration, we will change the client to an interface that will describe what we want to implement in different variants. And we'll move the old Star Wars client code to static Star Wars client that implementing this interface. In the interface, I will also introduce single dispatch method. Who knows the single dispatch method? What it is? Okay, nice. For other, it will be scary. So we have static method get client. So it is our factory for this interface, and it gets any settings. And any settings is not a good setting. We don't want to handle any settings, so we are raising unsupported configuration. But single dispatch method allows us to implement different variants of the same function based on the type. So we can say that we are registering another implementation of getClient. That is also a static method, but this time settings are static type. So it is our configuration type static. And this time we are returning static Star Wars client. And we can register another implementation that expects API settings, and this will return API Star Wars client implementation. So something totally different. How to use that in our projects? So we can create a settings factory that is a dependency that we will use to access settings through all of our fast API project, and we will change how get Star Wars client was implemented. So this is the old dependency. This dependency now will depend also on settings dependency, so we can change dependencies, and it will just run the Star Wars client get client factory that we previously saw with this single dispatch method. Yeah, it is tough, right? So let's make it clear how this combination of settings and static single dispatch method works. If we have our simplified version of settings without all the details, if we have static type of our Star Wars client configuration, we will call this registered method that expect static configuration. But if we receive API settings from environment variables, we will call a different function that expects API settings and will create a different client. And when we are using in dependency this get client, it will be magically called precisely what we want to do. So how to test those things in more advanced projects? So if we want to implement our API client, we will just create a tiny configuration only for API settings. We don't need to prepare the configuration for the whole project if we split it in a smaller chunks. So we are only preparing API settings. We are initializing our new client, just calling the Starship and doing assertion. This test is super easy. If we write our code in a good way, writing this is pleasure, and using TDD is also very easy, even in a huge projects. And Also, if we want to do more of integration tests, so we want to test the whole application, it is also quite easy to use this configuration and like override some things. So in the test, I'm using a test settings fixture that prepares another implementation of test settings. If, for example, debug equals true, usually I'm overwriting some database, etc. But right now I'm only changing this field, and I'm using that test settings in client. So we saw the client previously in test when I was calling the API. So here is the fixture that actually returns test client from fast API. But this time I'm doing something magical, I think. So we have override settings function, and we are calling our main app object. So it is when we in our main file we have app equals fast API. This is this app, and we are using dependency override where settings, the keyword for this dictionary, is a settings function that was returning our settings previously, and we are replacing it with overrided version and just returning test client app. That's a lot, right? But all of that we can summarize as an art of destroying software. And if you are not familiar, this is a name of a talk given by Greg Young. It is not on the YouTube, at least it was not. It is on Vimeo. So it is a little bit difficult to find, but it's a great talk when he described that we should focus on removing features. We saw that less code is less bugs, right? On the one of the, I think, keynotes. So if you focus on the way that you will be able to easily remove the code from your code base, it will be also easier to add the code. And during this talk, we were using a lot, and I say a lot, of different design patterns. So we were using advanced typing. Everything was super strictly typed. Pydantic was securing all the input to our system. There were no places for mistakes, and we are using Pydantic built-in features, so it was not that complicated to use it. We were using object-oriented programming, so not like if you are using the class keyword, you are using object-oriented programming. No. Usually when people use class keyword, they are still programming in the old paradigm. And object-oriented programming is the place where we use this URL property. That was object-oriented programming because we were keeping the functionalities close to place where they were using the object that was knowing everything about that. We are using dependency injection. So thanks to Sebastian, he introduced dependency built-in fast API, and it's really, really super easy to use it. We use clean architecture. We use open-close principle. What does it mean? Our code is open for new features, but closed for modification. If we would like to implement another class for implementing Star Wars client, we would only add new functions. And if we delete something, we will only delete whole blocks of code. We will not modify any functions. We'll just delete the whole functions. And that's super easy without modification of functions body. We were using polymorphism. We are using single responsibility principle. So when we had a different kind of databases, right, SQLite and Postgres, they had separate classes for storing their configuration. We didn't mix everything in a single class because it was easier. And we were agile. And I don't mean agile like we had stand-ups. I'm only standing up. And we didn't use Jira. We were agile. We are flexible using all those principles. We can easily change, modify, improve our functionalities. And thanks to that, we could also use TDD and use it daily on our work. Thanks all of you for the talk. Here is the link to my page where you can find the GitHub repo with everything. And in GitHub repo for this talk, in the commits history, there are all steps that I taken. So you can not only go through the code by itself, but also check the history, how it looks like, how I step-by-step work, and there are some descriptions how it was. Thank you very much.
Thank you for the amazing session, Grzegorz. So because time is up, we not have Q&A now, but if you have questions, you can post on the Discord channel and you tag the speaker, or you can approach him personally. Thank you.
Thank you very much.